Hello everyone, today we're going to talk about interior angles in triangles, specifically the triangle sum theorem or triangle interior sum theorem. This is section 5A.3 in case you are looking for the attached practice in Canvas. Today specifically we will talk about the triangle sum theorem. I will leave the right side of the notes blank. The triangle sum theorem is about the interior angles in a triangle, and it says that every single triangle, every single time, all three interior angles will always sum to 180 degrees. We've talked about this in class before, but we want to kind of put a name to it. This isn't the definition of a triangle. So if somebody said to you, what's the definition of a triangle? You would not say 180 degrees. You would say it's a shape that has three sides. The triangle interior angle sum theorem just means that in every triangle, no matter what it looks like, here's an example. I'm just going to draw a pretty basic looking triangle. No matter what the triangle looks like, all three of these angles will add up to 180 degrees every single time. No matter if all three angles are the same measurement or if all three are different angle measures, this particular theorem is telling us that every single time, this is always, reliably, the angles that are inside the triangle are going to add up to 180 degrees. And once again, we're specifically talking about the inside of the triangle, not the exterior angles. We'll talk about those later. Each triangle has three interior angles. Generally, if we wanted to talk about this in terms of like an equation or something that might make a little bit more sense than just a theorem, is if we were to write that the measure of angle 1 added to the measure of angle 2 added to the measure of angle 3 has to be 180 degrees every single time. And then you can label these in a triangle always if you want to. 1, 2, and 3 are arbitrary labels. You just know that every triangle is going to have three angles. So in this particular angle, you have in this particular triangle, you have three angles. One of them measures 35 degrees, the other measures 80, and then the third triangle, or the third angle in the triangle, has a measurement that we don't actually know. If we use the triangle sum theorem, we know that all three of these angles have to add up to 180 degrees. So if two of them have 80 degrees and 35 degrees, then the third angle has to be a number that will get up to 180 degrees. If two of the three angles have these measurements of 80 and 35, if I am to combine those, 80 degrees and 35 degrees come together, and that means that total in this triangle, 115 of the degrees are taken up. I need to get to 180, and 115 isn't quite there. So my little equation now is really just a one-step equation, because I have 115 degrees taken up by two of the angles, but I need to figure out what's left over. So I'm going to subtract 115 from both sides, just like I would in any regular equation, and I end up with 180 minus 115 to find out that the measure of angle 3 has to be 65 degrees. This is something that you can do with every single triangle, whether it's algebra or not. Every single time, every triangle, always, the interior angles will make 180 degrees. And you can always check and say, do 180 or do 80 plus 35 plus 65 make 180, and if they don't, then you know that you've done something wrong. Let's look at a more challenging question here. This is a little bit more complicated looking. The first thing that I notice about this picture is a set of vertical angles. So I'm going to go ahead and draw those little angle arcs. What I know about vertical angles is that they are exactly the same measurement every single time. So I have two triangles here where I know two of the angles in the first triangle. So there's a 40-degree angle and a 30-degree angle. Together those make 70 degrees. So if I want to find the third angle in the triangle, which is one of the vertical angles, I have to take those 70 degrees and then subtract them from 180, which means that that third angle in the triangle has to be 110 degrees. So I've used the triangle sum theorem here. Now I'm using vertical angles. I know that those are congruent. So one of the angle measures in this second triangle has to be 110, and the other one is 25. Together, if this is a triangle, so far I have 135 degrees from those two angles. So I got to figure out what my third angle is. If I do 180 and then I subtract 135, that tells me that there are 45 degrees left over, and that has to be the angle measurement that I'm asked for in that particular example. All of our angle relationships still exist, supplementary, vertical, all of those. It's really important here that you're just asking yourself, where is the triangle and what are the three angles that I'm looking at? Okay, let's add a little bit of algebra in here. If I'm looking at this triangle, I notice that I have an 80-degree angle up top, and then I have two expressions, 9x plus 4 and a 16x minus 4. If these are the three angles that are going to make up my triangle, I know that they have to add up to 180 degrees. So I'm going to start writing out this really long equation. 9x plus 4 plus 80 plus 16x minus 4 is equal to 180 because those are all three of the angles in the triangle. Next, I have to combine some like terms. So I have a positive 9x and a positive 16x. That gets me to 25x's. Then I have to combine my constants. So I have a positive 4 and a positive 80, which gives me 84. 84 minus 4 is 80. So on the left-hand side, I have 25x plus 80, and that has to be equal to 180 degrees because, once again, I'm talking about a triangle. So 180 is the magic number. This is a two-step equation, so to get the x by itself, I need to first subtract the positive 80, and that means that on the left-hand side, the 25x is the only term over there. It's just 25x's, and that's great. And on the right-hand side, I have to do 180 minus 80, and that gives me 100. Then I divide by 25 on the left and the right, and then 100 divided by 25 is 4. So I have successfully used the triangle sum theorem to find out that in this particular triangle, the x is equal to 4. I could plug that in and find the angle measures, but I'm not asked to do so.